One of the most common questions you're going to be asking when you open a new capture where you don't really understand what's going on is, where are the weird things at, right? Where are the dragons, so to speak? Where are the things that shouldn't be here? And of course, that's not the easiest question to answer. And there's a lot of ways to go about it. Certainly, to understand what shouldn't be there, what's out of place, you need to understand what normal looks like. So understanding normal protocol transactions and things like that's important, which is why we devote several sections to it later on. However, Wireshark does provide one useful feature that I think is really helpful for finding things that are not necessarily problematic, but may warrant some attention. And it does this with something called expert information. Now, I don't really know why they call it expert info, so to speak. I don't think that's necessarily the best name for it. You don't have to be an expert to use it. You can use it with no skill or ability at all. So it's something that I think is pretty useful for looking for specific types of protocol anomalies. And quite honestly, it's maybe probably a little underutilized, both by the developers of Wireshark to relay important information and by the users of Wireshark to actually find specific anomalies that are of interest. To view expert information for any capture file, we're going to click Analyze up here in the top menu and go down to the bottom and click Expert Information. And we'll be presented with a window like the one you see on the screen here. Now we're looking at a table of data, and we have a couple interesting columns. Now, the thing to keep in mind is that expert infos are really kind of a way of just showing uncommon or somewhat notable behavior based upon protocols. And these are indeed based upon protocol. You'll see here we have a protocol column here to identify that. So we have the ability to program into the protocol dissectors to look for specific types of things that might be of interest at varying levels. So the information you're going to get for this are going to be highly dependent upon protocol. I will say, kind of anecdotally, most of the things you're going to see here are going to be TCP related, because those are the things that are going to come up most often. After all, most communication on the network is going to be TCP. So you'll see most of those, and it's the one that's really the most fleshed out. There are not a lot of other protocols that have this ability to generate this type of data within Wireshark and that do it so verbosely. So this is mostly going to be used for looking at TCP related information based upon its current adoption level. And that's kind of been consistent throughout the history of Wireshark, as this is mostly for TCP information. Nonetheless, it's worth looking at. So you see on the screen here, we have a lot of different things going on. We have a lot of neat colors that help us kind of separate that visually. Now, these colors are based on this first column here, severity. You see we have warnings, we have notes, and we have chats here. So we have three different severity levels here that mean all different things. We'll actually start at the bottom here because chat is kind of one of the most inconsequential severities that we have here. A chat is information about a normal workflow for the most part, usual workflows, but it's things that are maybe notable and that have been programmed to show in here in the expert infos window. You see we have connection established here, and we just have two of those. So that's, of course, normal activity, but it's just a chat to say that, hey, this is where we noticed that a connection has been established. In this case, it looks like there were a couple of related packets here that are marked for that. Next up, we have notes. Notes are the things that are necessarily considered notable. Now, that doesn't mean they're errors, they're just notable, right? They're things that maybe don't occur all the time. We have a couple examples of that here. We see duplicate ACKs. So that's an issue we'll look at when we look at TCP latency later on. Duplicate ACK is a way to make sure that that an acknowledgement is received by a client, and so that's noted here. We also see some fast retransmissions here, which are another kind of TCP reliability feature we'll look at later. So these are normal things. Maybe if they were occurring in mass, like there are a whole lot of them at once, that would be something that's a little suspicious. But for the most part, this isn't anything to worry about, but it does bring it to our attention and allows us to go through and look at those different things. Now above this, we see warnings, and warnings are here in yellow, and they are considered maybe a little bit unusual, right? So this is where we're kind of increasing our threshold for maybe we should look at this. In this case, we see one that a previous segment was not captured. So it's obviously, it says it's common at the capture start, but that a particular packet segment is missing. And we also see that a frame here was out of order. So obviously the order of packets in which they're received, it kind of matters. TCP allows us to put things back in the right order with sequence numbers and acknowledgement numbers, which we'll talk about a little later. But this kind of calls that out. So these are things, again, not necessarily bad, but they're a little anomalous and maybe highly unusual or somewhat unusual at least, and maybe something you want to look at. Now, the thing we don't see here are any red entries, and that's the next level up. There are chats, notes, warnings, and then there are errors. We don't have any errors in here, and that's good. We don't want to see errors. Pretty much anytime you see an error, that's almost certainly something you at least want to be aware of. Errors are representative of pretty serious problems in most cases. Probably the most often thing you're going to see that's going to be red are malformed packets. So that's a packet that was received and was not able to be read by any particular packet dissector. So maybe something got corrupt along the way. Some software application was trying to send something and mangled it, and it wasn't properly formed. A lot of different things can cause malformed packets. Wireless communications, weak signal can cause them, for instance. But those would show up here as errors in the severity column. So again, of course, we have severity column, we have a summary column, which is where we're getting all these nice descriptions from. We have some grouping columns. We have our protocol, and we have our count that shows us our count of packets here. So it's a nice little concise window that shows you all these things, shows you the packet numbers so you can browse around and find those things. It can be pretty helpful for spotting things that might be of interest, at least in this case, specific to TCP type of anomalies and information. Now, pulling up the expert information window is just one way to see this data, but these colors mean something. You'll notice Wireshark actually shows us these specific entries in the actual capture file itself, so in the packet list and packet details window. So you notice here our chats are blue, and we see here that packet 1 is actually considered a chat. And if you look behind me here, you'll see that the TCP protocol is highlighted in this blue color. So I'm actually going to go ahead and click out of this and look here, and look, we have this TCP header here, and it's highlighted blue. And you may have noticed that to this point and wondered why that is. And that's actually because there's some expert information that's located there. So I can actually expand this and see that the flags section is highlighted blue. So I can go down here, see that the send bit is set, and under here we have expert info. It's a chat. For connection established, request send server port 80. So we can see that information here, which is pretty darn neat. We can actually even see the severity level here. Now, one thing you can do if you're interested in looking at these things, maybe you're doing some latency troubleshooting. Again, that's probably the most common use case I've seen for using this. You can actually right-click this severity level information and apply that as a column. So now we'll see every packet that has expert info in it. In this case, we see some chats. If I scroll down, we might see something else. This is a pretty big capture, so maybe not immediately. But we do have a lot of things here. Now, for that matter, you can also filter on this information. So I can actually just click here on expert info, this top level header for that right here. And I'm going to go ahead and apply a filter for selected. It's going to apply this _ws.expert. And that's basically saying, show me all the packets that have expert information. And you'll see those here. So we have our 3 chats at the beginning. We have a warning. We have several notes. This packet has a couple notes, warnings, notes, and so on. So we have, it looks like 24 packets here that happen to have some type of expert info in them. So this is just one specific packet capture, and it's one we're downloading a file that's not entirely successful. So it's probably not surprising to see a lot of these duplicate acts and things like that. Definitely representative of some potential network latency. So that's pretty cool. It allows us to look for those really quickly. Again, not a lot of super practical uses in every scenario, maybe like general troubleshooting, but definitely very useful for latency troubleshooting and sometimes for security troubleshooting as well. It might help you find things like malformed packets or high latency hosts. Certainly a lot of hosts that get compromised and host malicious material are a little oversubscribed because they're doing so much of that, and obviously the attackers don't care about the system resources. So you'll see slowness with a lot of compromised hosts as well. So that's something to be aware of. So play around with expert info, see what you can learn about it, open some different packet captures, the ones I provided, or get some of your own, and see what expert info can provide you, especially in relation to TCP. And we'll revisit this as we continue on.